Problem number 17, the problem on slide number 17 reads, a ball of mass m and radius r rolls without slipping along a level surface at speed v. What is the maximum vertical height that the ball can roll up to if it ascends to an inclined plane as shown below? Alright, so we have our initial condition is our ball is at the bottom of the inclined plane and it has a speed v, so initial velocity v. Now, this ball is gonna roll upward until such time that it reaches the maximum height where the object remains at rest. So at the final height, the object is at rest. So when the object reaches the maximum height, that object or this ball should be at rest. And this ball right here is a solid sphere. So this is one information that's missing, a solid sphere. Okay, in solving problems like this, we have to remember the law of conservation of mechanical energy. So according to the law of conservation of mechanical energy, U initial or potential energy initial plus kinetic energy initial should be equal to potential energy final plus kinetic energy final. And also a very important word that you have to remember here is, or that you have to take note, is roll up. Why is this so? Because when the object is rolling, let me take that down. For rolling objects, it will possess two forms of energy, two forms of kinetic energy. What are those? What are the two forms of kinetic energy? Let me begin with Abdullah Ali. Abdullah Ali.
Mr. Muhammad says he cannot join. He cannot listen.
Abdullah Ali Ahmed.
Okay, that's me.
Abdullah Ali Ahmed.
Yes, Mr.
What are the two forms of kinetic energy?
Kinetic energy initial and kinetic energy final.
That's state of kinetic energy. When I say form, there are two forms of kinetic energy. In fact, they have different formulas. What are those? Let me move on to Abdullah Ali Hassan. Yes, tell me.
Rotational and transitional.
Very good. So for rolling objects, a rolling object will possess two forms of kinetic energy. We have rotational kinetic energy and translational kinetic energy. So because a rolling object is rotating and at the same time moving or covering a certain linear distance. What is rotational kinetic energy equal to? Abdul Rahman Naif. What's the formula for rotational kinetic energy?
Master, I don't remember, but I think it is.
Abdullah, thank you, Abdullah Ali Hassan. Let's.
No, it's 1/2 IW squared.
All right, that's 1/2 I. It's not W but omega squared. What is I? I need to speak with Abdul Rahman. Abdul Rahman Naif. Abdul Rahman Naif.
Yes, Mr.
What is in the formula Kr is equal to, or rotational kinetic energy is equal to 1/2 I omega squared. What is I?
Mr. I don't remember.
Sir, I know.
I'll proceed with yes, Said Abdul Rahman. What is
It's the inertia in motion.
Very good. It's the moment of inertia.
Moment.
What about omega? What is omega, Said?
Omega, unit of omega.
What is omega?
Teacher, I forgot to.
Yes?
Mr. Me, Muhammad Jassim, I know.
Raise your hand if you would want to answer. Yes, Haza Salem.
It's angular speed.
It's angular speed. Very good. So I is moment of inertia. Please take note of these information. I actually have given this in the Ed puzzle task. So if I would tell you take note, make sure that you actually take note of it. All right. Yes, Muhammad Nasser, you're raising your hand. What is K translational or kinetic energy translational equal to?
Half mv square.
All right, that's 1/2 mv squared, where m is mass and v is your velocity. Okay, so since our object is rolling in this case, our kinetic energy would come in two forms. We have rotational kinetic energy and translational kinetic energy. So I'm going to expand my equation. I will have ui plus kt initial plus kr initial is equal to u final plus kt final plus kr final. All right, moving forward. What is potential energy equal to? What is potential energy equal to?
Initial.
Potential energy. Just let me know what the formula for potential energy is. What is potential energy equal to? Any let's see, Hamad Ahmad Khalil. Absent. All right, Hamad Ahmad is absent. Let's see.
Mister, can I answer?
No, I'm gonna be calling according to the list that I have here with me. Let's see. Ahmad Rashid. Ahmad Rashid.
Yes, Mister.
What is potential energy equal to, or U? What's the formula for potential energy?
Mr. MGH.
Very good. That's mgh. Now, having said that potential energy is mgh, let's look at the initial potential energy. Can anybody tell me why initial potential energy is 0? Why is initial potential energy, or UI, equal to 0? Yes, please raise your hand, and then I will let you speak if I would recognize your name. Yes, Muhammad Yusuf. Why is initial potential energy 0?
Because Mr. the object is at rest and it's not moving.
It is not at rest. In fact, the object is actually moving at an initial speed v. The object is not at rest. If it's at rest, if it's initially at rest, then this object will not be able to go up. It's not gonna be able to go up if it's at rest. It's not at rest. It is initially moving at a speed v. I'm looking at potential energy. Yes, Muhammad Nasser. Why is initial potential energy equal to 0?
Because the height is equal to 0.
Very good. Because the initial height of the object is 0. It is at the bottom of the inclined plane. And if potential energy is mgh, so the height is going to be 0. So therefore, the potential energy is 0. And therefore, the initial potential energy, since the object is at the bottom of the inclined plane, is equal to 0. Yes, Muhammad Nasser.
What was the question?
No, you're actually raising your hand. That's why I called your attention.
Oh.
Okay, so again, potential energy is equal to, initial is equal to 0. Now, can anybody tell me, oh, wait. Will the final potential energy be 0? Yes or no, and why? I would like to speak with, let's see. Yes, Muhammad Jassim. UF, is it gonna be 0? Yes or no, and why?
No, because the edge won't be 0.
Very good, because you're fine. The object is now elevated at a certain height, so therefore your potential energy final is not gonna be 0. However, our potential energy translational, our kinetic energy translational is gonna be equal to 0. Our KTF is going to be equal to 0, and our KRF is equal to 0. And of course, I'm gonna ask you why. Anybody? Why is KT final? Please raise your hand. Please raise your hand if you'd want to answer. Do I only yes, Hilal, go ahead.
Mr. Because it reaches the maximum height.
Uh-huh. And at the
So,
maximum height?
And it's at rest on the max.
Very good. At the maximum height, if we remember, if you remember projectile motion, when an object would reach its maximum height, this actually means that the object's velocity at that point is 0. So it's gonna be at rest. So therefore, if it's at rest, translational kinetic energy would be 0 because the velocity is 0. And if it is also at rest, rotational kinetic energy would be 0 because the angular velocity is also gonna be equal to 0. Any questions so far? Questions before we proceed? No. All right. Now, another very important thing that we need to remember in solving this problem is the shape of the object. Why is it important to know the shape of the object? Why is it important to know that this ball that we're talking here is actually a solid sphere? Anybody?
Because Mr.
Raise your hand, please. Yes, Haza?
Mr. Because if it's like another shape, the moment of inertia will change.
Very good. All right. So Haza, since this is a solid sphere, what is the moment of inertia of the ball? I is equal to, where can we find that information? All right, go to class kick slide number 1. Can anybody give me that? Yes, Hilal, do you have that information?
Yes, I equal 2 over 3 mr squared.
Is it 2 over 3?
No, 2 over 5.
All right, that's 2 over 5 mr squared. All right, and then after that, you are going to expand your KTI. You're going to expand your KTI, your KRI, your UF. You should be able to give me the answer to this problem. Any questions?
No.
All right.